Softfoot is a condition that affects your alignment and shortens the life of your machines. It's actually distortion of the machine frame, not the machine feet. A perfect example of softfoot is when you sit at a table and it rocks back and forth. Is this type of situation also bad for machines? Absolutely. The deformation of your machine will cause the bearings inside to be out of alignment and cause the shaft to deflect. Machines are built out of many parts machined within close tolerances. The distortion of a machine from softfoot causes all those precision machined parts to move out of alignment. Softfoot also causes shaft deflection. Let's put this into perspective. A typical machine running at 1800 RPM with a softfoot condition could force the shaft to bend back and forth 30 times a second, or 2.5 million times every 24 hours. Think about what this increased vibration would do to the reliability of your machine. Okay, so now we know we have to get rid of softfoot, but that's where the mystery usually begins. Correcting softfoot does not have to be an art, and correcting it can be made easy once you understand exactly what is going on and exactly what to look for, and we're going to show you how to do that. After the lockout tagout, we're going to do 3 things: a rough alignment, a rough softfoot check, and a final softfoot check. Let's begin our rough alignment. Clean and prepare the area under and around the feet. We want to make sure we don't leave anything behind that can get under the feet and cause distortion of any kind. This means loosening all of the hold-down bolts and cleaning out any dirt, grease, rust, or scale. By doing this, you'll have good metal-to-metal contact, and you won't give the foot anything to compress on when you tighten the bolts. Now you can start your rough alignment. The point is to get it eyeball clean, so don't spend too much time on it. Once this is completed, you can begin your rough softfoot check. If you're aligning a motor to a pump, it is also a good practice to check for softfoot on the pump. The API 686 spec recommends the pipes be disconnected from the pump before a softfoot check. Now that the area has been prepped with the bolts still loose from performing the rough alignment, fill in any of the obvious gaps that exist between the feet and the base. When going around to each foot, remove and inspect the existing shims. If you see any shims that are bent or crinkled, replace them. Consolidate shims and make sure you have no more than 3 or 4 shims under each foot. All the shims should be snug under each foot when the hold-down bolts are loose. During this rough softfoot check, determining the amount of shims to place under each foot can be accomplished by dial indicator or by the feeler gauge method. The dial indicator only reveals how much the foot rises when the hold-down bolt is loosened, but will not reveal how much of an angle the foot has. We recommend using feeler gauges to measure the gap under the corners of each foot to make sure the angle is captured. Is that it? Do we just fill in the gaps and remove pipe stress? Definitely not. This is only part of the softfoot check. Along with shortening the life of your machinery, a big problem with softfoot is that it hampers your ability to perform an accurate alignment. Let's go back to our table example. You may stick your napkins under the bad foot and get the table to stop moving. But this is not a permanent solution. If you still have softfoot, you'll be chasing shim corrections that don't seem to match up with the alignment readings. Moves will also be difficult because the alignment of your shaft center lines of rotation will change as soon as you retighten the bolts. If you find yourself in this situation, remember that it's not your fault that your alignment is difficult to achieve. The problem is that you still have softfoot. Because eliminating softfoot is such a critical factor in any alignment, all Proof Technique laser shaft alignment tools feature a softfoot function. What it does is measure how much the shaft deflects when a hold-down bolt is loosened. From this, it calculates the severity of movement for that softfoot. Just like an X-ray allows a doctor to see what's wrong, the softfoot function reveals problems you wouldn't normally be able to detect with just a rough softfoot check at the feet. By using this function to eliminate the last of your softfoot problem, you will be assured a trouble-free and easy-to-accomplish alignment from that point forward. When you started the rough alignment, you already set up the sensor and laser on the shafts, so there's no need to break out any additional equipment. Let's now begin our final softfoot check. Simply loosen one hold-down bolt, with the other 3 feet tight, and let the Rotoline Ultra measure the shaft deflection. Then, retighten the bolt. Move to the next bolt and repeat this process for the remaining bolts. The numbers displayed are the calculated values for the shaft movement at each hold-down bolt position. If your displayed values are less than 2 mils, you have no significant soft foot, and you can proceed with the rest of the alignment. If your soft foot values are greater than 2 mils, then you have a soft foot that needs to be addressed. Be aware that the numbers are not necessarily the actual gaps under the machine feet. When loosening and tightening the hold-down bolts, we are measuring the effect of that particular foot on the shaft deflection, not the actual gap. If soft foot was detected, we will then measure the true gap under those feet using a feeler gauge. With this technique, we can determine the exact soft foot condition, such as a parallel air gap, bent foot, or deflecting base. While most gaps under a foot can be filled with pre-cut shims, a foot that is angled or bent requires a step shim to fill in the gaps. So let's do an example soft foot measurement on this motor. All 4 feet are measured for soft foot. The numbers indicate that the values on the opposite corners are higher than 2 mils, indicating that these 2 feet are causing a soft foot. 1 foot is loosened and a feeler gauge measures the exact gap under the 4 corners of the foot. These values are recorded. The foot is retightened and the opposite foot is inspected in the same manner. Notice that the feeler gauge readings show that the feet have more gap in the outer corners of the foot. This is an example of a rocking soft foot. While it may seem that both feet are bent, what is actually happening is that the machine rocks to the side to create a gap when the feet are tightened. The solution is to simply shim 1 foot to get rid of the gap. So what if you don't have years of experience with soft foot? Before you gain enough experience to diagnose on your own, the Rotoline Ultra's Soft Foot Wizard will help you. The Soft Foot Wizard is your highly experienced field companion that walks you through the process step by step, guiding you graphically through the most efficient techniques of soft foot correction. The Soft Foot Wizard diagnoses your problem and solves it with instructions that are very clear and easy to understand at all experience levels. Once you complete the Soft Foot Wizard, the final value should be less than 2 mils, which means the soft foot has been removed. With this taken care of, you can now finish the rest of the alignment.